Disney spent $25 billion building a dream in the middle of a Florida swamp, and the swamp is winning. Not metaphorically, not as a rhetorical flourish about corporate hubris or the limits of human engineering. Literally, the wetlands and the hydrology and the subtropical ecosystem that Disney's Imagineers spent decades trying to contain, redirect, manage, and subordinate to the needs of the most visited entertainment complex on Earth are pushing back in ways that the engineers who designed the drainage systems, the catch basins, the retention ponds, and the water management infrastructure underneath and around Walt Disney World did not fully anticipate, and that the current management of the resort is struggling to address without disrupting the guest experience that generates the revenue that justifies the investment. The catch basins are overwhelmed. The retention systems are at capacity. The water that Florida's climate produces in quantities that have been intensifying with each passing year is going places it is not supposed to go and coming up through surfaces where guests are supposed to be walking and standing and spending money. And the gap between the public image of Walt Disney World as a place where everything works perfectly because Disney makes everything work perfectly, and the physical reality of a 27,000-acre facility built on top of one of the most hydrologically complex and ecologically active landscapes in North America is wider right now than it has been at any point in the resort's 50-year history. To understand why this is happening, you need to understand what Walt Disney World actually is at a physical and geological level, because the marketing version of the story, Walt Disney's vision, the Florida Project, the most magical place on Earth, strips out the engineering reality that makes the fantasy possible, and that is now making the fantasy increasingly difficult to maintain. When Walt Disney and his team began secretly acquiring land in Central Florida in the early 1960s, what they were buying was not pristine wilderness and not developable suburban land. They were buying swamp. Specifically, they were buying a mosaic of pine flatwoods, cypress swamps, wet prairies, and shallow lakes. It sat on top of a geology that is essentially a thin layer of sand and organic material floating on top of a limestone karst system that is riddled with sinkholes, caves, and underground conduits, conducting water through the rock in ways that the surface topography does not predict and that engineering intervention cannot fully control. The water table in the area that became Walt Disney World sits at or near the surface for significant portions of the year. The annual rainfall in Central Florida averages around 54 inches per year, but it does not arrive evenly. It arrives in an intense wet season from June through September, during which thunderstorms capable of dropping 2 to 4 inches of rain in a single hour are a daily occurrence. Building anything on this landscape that is going to remain dry, remain stable, and remain functional requires continuous active intervention in the natural hydrology of the site. And that intervention has a cost that compounds over time as the infrastructure ages, as the climate intensifies, and as the swamp asserts the ecological persistence that characterizes every wetland system on Earth. Disney's engineering response to the challenge of building on a Florida swamp was genuinely extraordinary, and it deserves credit as one of the most ambitious civil engineering projects in the history of American commercial development, before a single, themed structure was built on the property. Disney's engineers dug a system of canals, ditches, retention ponds, and catch basins across the entire site that was designed to intercept and manage the water that Florida's climate would deposit on the property and that the underlying geology would conduct upward from the shallow water table. They raised the grade of the areas where they intended to build by importing fill material, lifting the building pads above the natural floodplain. They constructed the famous utilidor system, the network of underground corridors that runs beneath the Magic Kingdom, allowing cast members and utilities to move without appearing on the themed surface above, by essentially building the park one story above the natural ground level and treating what guests experience as ground level as actually being the roof of an underground facility. This was necessary specifically because of the water table. Digging down into the Florida soil at that location immediately encounters groundwater, and the utilidor system could not have been built as a conventional below-grade tunnel without continuous pumping to keep it dry. The water management system that Disney built in the 1960s and early 1970s was designed for the climate and the rainfall patterns of Central Florida as they existed and were projected at that time, and it functioned adequately for the first several decades of the resort's operation. The retention ponds that dot the Disney property, many of them disguised as decorative water features or integrated into the themed landscape of the various resort areas, were sized to handle the rainfall volumes that the historical records suggested they would receive. The canal system was designed to move water off the property at a rate that the engineers calculated would prevent flooding of the developed areas during normal and moderately abnormal rainfall events. The catch basins were positioned and sized based on the drainage patterns of the graded and paved surfaces they were designed to serve. It was a sophisticated system. It was built with significant engineering margin. and it is being overwhelmed because the assumptions it was built on are no longer accurate. The intensification of Florida's wet season rainfall in the context of a warming climate is not a projection or a model output at this point. It is a measured and documented trend visible in the rainfall records of Central Florida across multiple decades. The storms that arrive during the June through September wet season are producing higher rainfall totals per event than the historical averages that Disney's water management infrastructure was designed around. The frequency of extreme rainfall events, storms capable of producing 2 inches or more of rain per hour, has increased. The wet season itself has been extending at both ends, beginning earlier in the year and persisting later into the e-fall than the historical pattern predicted. And the cumulative effect of these changes on a drainage and retention system that was sized for a different climate is exactly what you would expect. The system is regularly receiving more water than it was designed to handle, and the excess water is going where water always goes when engineered systems are overwhelmed, which is everywhere the water can find to go. The specific manifestations of the overwhelmed drainage system at Walt Disney World are something that guests encounter more frequently than Disney's communication strategy acknowledges, and more frequently than the resort's social media presence, which is carefully curated to maintain the Magic IL experience narrative, would suggest. Standing water on pathways and in queuing areas during and after heavy rain events has become a routine occurrence in multiple areas of the property. Water intrusion into ground-level facilities that are supposed to be dry has been reported with increasing frequency by both guests and by current and former cast members. The landscaped berms and planted areas that Disney uses to screen the resort from its surroundings and to create the immersive environmental separation between the themed areas and the outside world are in multiple locations, showing the stress of waterlogged soil conditions that the plants installed in those berms were not selected to tolerate. The retention ponds are at levels that leave them with reduced capacity to absorb the next heavy rainfall event before it occurs, which means that each successive storm event during the wet season finds the system with less available buffer than it would have had if the previous storms had fallen within the design parameters. The interaction between Disney's water management infrastructure and the underlying karst geology adds a dimension to the problem that surface drainage engineering alone cannot address. The limestone beneath Central Florida is not a stable impermeable substrate. It is a dynamic geological system that is continuously being modified by the movement of water through its fractures and voids. Sinkholes are a routine feature of the Central Florida landscape, and they are not evenly distributed. They tend to appear in areas where the overlying sediment layer is thinner, where water concentrations in the soil have been elevated by development-induced changes to the drainage pattern, and where the limestone beneath has been progressively weakened by dissolution over time. Walt Disney World has experienced sinkhole activity on the property since its opening, and the management of that activity during our monitoring, filling, stabilizing, and in some cases redesigning facilities around areas of sinkhole risk is a continuous operational cost that the resort's public communications do not highlight. The intensification of rainfall and the increased water loading on the soils of the property from the overwhelmed drainage system is not improving the sinkhole situation. The $25 billion investment figure that frames this story is the number that Disney itself has cited as the scope of its capital investment in the Walt Disney World Resort across its history, and the number puts the water management challenge in a specific financial context, $25 billion. Allures of infrastructure, of themed environments, of hotel rooms and restaurants and retail and transportation systems and entertainment facilities is sitting on top of a landscape that is increasingly asserting its fundamental character as a Florida wetland. The return on that investment depends on the resort continuing to function as D, assigned, continuing to provide the guest experience that commands the premium pricing that makes the financial model work, and continuing to attract the visitor volumes that fill the hotels and the parks and the restaurants. Every instance of standing water in a queue area, every flooded pathway, every water intrusion event in a facility that guests paid significant money to spend time in, is a small erosion of the guest experience that the investment depends on delivering. They are individually small and collectively significant. The political dimension of Disney's water management situation adds a layer of complexity that makes the problem harder to address than a purely engineering challenge would be. The relationship between Walt Disney World and the state of Florida has been in an unusual condition since the political dispute between Disney and Governor Ron DeSantis that resulted in the dissolution of the Reedy Creek Improvement District, the special governmental entity that Disney had operated since 1967, and that gave the resort extraordinary autonomy over its own infrastructure, utilities, and land use decisions, including its water management systems. The replacement entity and the changed relationship between the resort and the state government have created uncertainties about the approval process for infrastructure modifications, and about the regulatory framework within which Disney can make the changes to its water management systems that the current situation requires. The engineering challenge of an overwhelmed drainage system is difficult enough in a stable regulatory environment. It is more difficult in an environment where the relationship between the resort and the governmental entities that regulate it is in an unsettled condition. The competitive context matters too, because Disney is not making its water management decisions in isolation from the financial pressures of a theme park industry that has been through significant disruption, and that is competing intensely for the discretionary spending of consumers who have more entertainment options than at any previous point in history. Capital that could be invested in upgrading and expanding the resort's drainage and water management infrastructure is capital that is competing for allocation against investments in new attractions, new hotels, new entertainment offerings, and the technology infrastructure that the modern theme park experience requires. Water management infrastructure is invisible to guests when it works and only becomes visible when it fails. In a capital allocation environment where every dollar has multiple competing claims on it, the investment case for proactive drainage system upgrades faces a structural disadvantage against investments in things that guests can see and respond to positively. The Florida Swamp does not care about capital allocation priorities. It does not care about the political relationship between a media company and a state government. It does not care about the guest experience narrative or the stock price or the $25 billion of investment that sits on top of it. It has been a wetland for thousands of years, and it retains the ecological and hydrological character of a wetland beneath and around everything that has been built on it. And it will continue to assert that character with increasing force as the climate that drives its hydrology continues to intensify. The catch basins are overwhelmed because they were sized for a Florida that no longer exists. The retention ponds are at capacity because the rainfall that is filling them exceeds the design assumptions that determined how large they needed to be. The water is going where water goes in a Florida. Swamp, which is everywhere, into everything, through every gap in the engineering, that the engineering did not seal completely. Disney built a dream in a swamp. The dream is still there, so is the swamp. And right now the swamp is winning.